Today in this class we'll discuss about integrated rate equation of first order reaction. First order reaction means that if the rate of the reaction is depending on concentration to the power 1, then it is known as first order reaction. For that first order reaction, we'll be discussing about integrated rate equation. If the reaction is R gives rise to product, R gives rise to product. If rate law is written that R is proportional to concentration of R to the power 1, this is known as first order reaction, right? Here rate of the reaction is proportional to the first power of the concentration. First power of the concentration of the reactant. If you are considering that the rate of the reaction is depending on concentration of only one substance, then you will be taking power 1. If it is depending on more than one substance, for example, if R1 and R2 are giving rise to product, this first order reaction can also be like this also. R is proportional to R1 to the power 1 by 2, R2 to the power 1 by 2. This is also first order reaction. Or if you are writing R is proportional to R1 to the power 1 by 4 and R2 to the power 3 by 4. This is also first order reaction. But in this example, we'll discuss about the first order reaction where that depends on concentration of only one of the reactor. So for this, if this reaction R gives rise to product, you know the rate law as it is given that rate law R is proportional to R to the power concentration of R to the power 1 as it is a first order reaction. When we remove the proportionality constant, we will be taking R is equal to K into the concentration of R. For this reaction, if you write rate of the reaction, R equals to decrease in concentration of reactant by time, right? So change in the concentration of reactant divided by change in the time. Take this one as first one and this is the second one. When you equate 1 and 2, so here it is R equals to, here also R equals, right? It means that these both are equal. You can write this as minus dr by dt equals to K into R. To take dr by dt, that will be equals to minus K into concentration of R. You bring this R to this side because you are going to differentiate, sorry, you are going to integrate both the sides, right? So it will integrating both the sides. For integration, there should be the d. If there is any term dt or dx or dr or dy like this, then only we will be integrating. So here this r we will take this side so that here also r, here also r. So your integration will be easy. Now dt you will take that side. Then you can write finally dr divided by r. Right. So here the change with respect to r here. Here we have r equals to minus k into dt. Understood, right? R and with respect to R. So both should be in the same side. As it is a constant and also this dt is in the denominator, then it will be difficult to integrate. So you take this dt to the numerator, then it will be easy to integrate. Now dr in the numerator, dt is also in the numerator, then it will be easy for us to integrate. Now how do we integrate? In the last class I explained integration and integration and d will be cancelled, right? If only d is there. Now this one dr by r, we have formula that dx by x integral dx by x equals to ln of x plus constant. You must have learned like this: 1 by x into dx equals to ln of x plus c. The same thing we have, you see, with respect to x and x in the denominator. With respect to r, and r is the denominator, so you will be writing ln of r. So that one will be written as ln of r. And in the right hand side, we have minus k dt, as minus k is constant. So you'll take minus k out and integral dt. So nothing but minus k into t plus I, where I is, so after the integration, you'll be taking the constant, that I is the integration constant. So this is ln of r equals to minus kt plus I. Right, we are doing the integrated rate equation of first order reaction. Right, but we have something like the I, right? And also here we have not related with initial concentration of the reactant. So you can relate initial concentration of the reactant and the concentration of reactant at any time when you take these conditions, like take the reaction concentration of reactant and the time t. At initial means if the reaction is about to start, you take the concentration of reactant as R0. So here time t means the reaction has not started. The time taken is nothing. So the reaction is about to start. You will take the time is 0. When you substitute these two values to this equation, let us consider this equation is 1. So if you substitute this to the equation 1, then what we will get? ln of the initial concentration is R0. When the time is 0, the concentration of reactant is R0. Here it is plus I. So k into 0, right? Anything multiplied by 0, whether it is minus k or plus k, it will be 0. So ln of R0 equals to I. Now ln of R0, right? So even this one you can substitute in place of I. Take this as 2. It means that you are substituting equation 2 in 1. So in place of I, you are going to take ln of R0. So ln of R equals to minus kt plus ln of R0. You can write this as ln of R equals to ln of, fine, like let it be like that only. Ln of R equals to minus kt plus ln of R0. For this one, if you draw the graph, okay, now let us compare this with y equals to mx plus c. Take this is y, this is m, x, and this one is c. Means what? On y-axis, what is to be taken? If this is the form, if you are taking ln of r minus kt plus ln of R0, if this is the form, what is to be done? You have to take ln of r on which axis? Y-axis, right? So now the slope, you see the slope here. So here ln of r is on y-axis, right? And on x-axis, what is to be taken? T. You may have doubt. Why don't we take m equals to t, x equals to k? See, on x-axis, you are going to take the values of t. Means time you are going to take, you are not going to take k. So x and t are equal. So here it is time t. And why we are taking in this quadrant? No, because ln of r and t value both are positive. And here you see the slope. Slope is minus k, right? And rate constant is positive value. So the slope value is negative only. See, negative minus positive, right? Negative into positive, it will be negative only. So slope value is negative overall. If you take the graph, what is maybe negative slope? Let us consider if this is the graph. If this is the graph and we have the values here, let us consider 1, 1. Here it is 2, 2. For this one, if you find the slope, y2 minus y1 divided by x2 minus x1. Take this as x1, y1. This as x2, y2. Then y2 minus y1 is 2 minus 1 divided by x2 minus x1 also 2 minus 1, where it is 1, which is positive. This is positive slope. The same time, you see, I'll draw the graph, one more graph like this. If this is the graph, so here, if this is the graph, let us take this point. If x value is 1, y value, let us take 3. Now in this point, x value will be more or y value will be more? This point, see, here, right, this is x. X value from here to here, it is increasing. So x value will be definitely more. But what about y value? Here y value is more, but here y value is low. So you take this as 1. The same way you do the slope x1, y1. You can take this one also x1, y1, this one x2, y2. However you take, no problem. This is x2, y2. Again, you will find the slope equals to y2 minus y1, 1 minus 3. X2 minus x1, 3 minus 1. Minus 2 divided by plus 2, which is equals to minus 1. So negative slope means it will be like this. This is how you will take negative slope on first quadrant, and this is how you will take positive slope on first quadrant. If it is passing through origin, if the x-intercept is 0, then you will take like this. If it x-intercept is not 0, then it can be like this. So here, what is the x-intercept? Sorry, y-intercept, not x-intercept, y-intercept. Y-intercept is ln of r naught. And the time here, right? Slope is minus k ln of r. You see, this is the intercept. Means this is the value, this is the point at which that line, that straight line is lying on y-axis. So you can take the line like this. You can take the line like this, right? Where the slope m equals to minus k. Slope is minus k. And this straight line, here it is touching on y-axis. This is called a y-intercept. This point is y-intercept. What is this point? ln of r naught. So this is how you will draw the graph. If the slope is negative, like this. If the slope is positive, it will be like this. When it is passing through the origin, it will be like this. I hope you have understood. Now this form, this equation 2, now let us take this as equation 3. Right? This equation 3 can also be written as, what do we have there? ln of r equals to minus kt plus ln of r naught. You can write this as ln of r minus ln of r naught equals to minus kt. Like this also you can write. When you multiply minus on both the sides, or you multiplying minus 1 on both the sides, then ln of r here, right, minus ln of r naught into minus 1 equals to minus of minus k. If you multiply minus, no, so this will be positive. ln of r naught minus ln of r equals to k. This one, how do we write? No, this is ln of a minus ln of b. ln of a minus ln of b is ln of a by b. Log a minus log b is the right. The difference between log and ln is that here power is e, for log the base is e, for a log the base is 10. So ln of x minus ln of y equals to ln of x divided by y. So this one can be written as ln of r naught divided by r equals to k into t. Now for this one also we can draw the graph. The graph will be like this also. For this one, how the graph will be, we'll check. Now take this axis. Previously we were doing by taking ln of r on the y-axis. Now we will take ln of r naught by r. Right? If this is compared with y equals to mx plus c, I am taking y, this one as y. equals to mx plus c, right? So x, time here. So time will be, you will be taking time on x-axis, right? Plus c. The slope is positive. M equals to k, where it is positive. K value is positive, right? Now time on x-axis, everything is over. Now kt is there, no? The ln of r naught by r equals to kt. You can write this one as plus 0 also. Correct? No, when you are adding 0, no change will be happening. So what is the intercept? 0. Where y-axis, and y-axis where it is 0, this is the point where it is 0. Intercept is 0 and the slope is positive. Then I already told, right? If it is positive like this, it should be like this, right? So where the intercept is 0, no? So you'll be starting from here, you'll be writing like this. So the slope will be positive and intercept, y-intercept is like this. So you can draw the graph like this, where the slope, how much, no, this slope, how much it is bent, that will be k, m equals to k. So this is also one of the graph. There is no difficulty in drawing these graphs. It is very easy. We should be knowing what is y equals to mx plus c. If you are able to compare with y equals to mx plus c, you can do any graph in this chapter. Understood? Now this equation, so previously we were taking equation 3, right? So now we'll take that equation 4. Take this as equation 4. Now from equation 4, what do we have now? Ln of r minus ln of r naught equals to minus k2. Like this only, take x and this is y. Then you can write this as ln of r by ln of r by r naught equals to minus k2. By taking anti-logarithm, we'll be getting r by r naught equals to e power minus kt. This is also one of the form. See, whatever the equations we have done so far, this one, right? Either equation 3 or equation 4, right? From this, you will be able to find k value, right? From this, you will be able to find k value when you know the initial concentration and the concentration at some time. So these two equations related to initial concentration and concentration at any time. From time 0, if time or initial time and final time. Final means some time at any time t or any time t. If these two are known, you will be writing that ln of r naught by ln of r naught by r equals to kt. From this, you will be finding k value. Understood? Or this one also be written as r divided by r naught equals to e power minus kt. This one also be written as concentration of r equals to r naught e power minus kt. From this one we can write k equals to, where k equals to 1 by t. This k will be here only, you are taking t that side. Then ln of r naught divided by r. This is ln, right? When you are changing these to logarithms, ln of x equals to 2.303 log x. This is the relation. So when you are changing ln to log, it will be multiplying with 2.303. Now this one can be written as k equals to 1 by t into 2.303 log concentration of initial concentration of reactant divided by concentration at some time t. So this is about first order reaction where you know initial time and any time t. Now we will do in second case. Now we will do initial time and the final time. Where initial time is not 0. Initial time is T1 and the final time is T2. Reactant time. Initial time, first row, initial. Previous case, we were taking initial is starting before the reaction starts. Now you will take this constant, initial is R1, time is T1. And final concentration is R2 and the time is T2. For this one, we already know some equations, right? ln of R equals to, substitute this value in the equation, ln of R equals to minus KT plus ln of R naught. When we substitute in this, what we will get now? In place of R, if you take R1, then time will be T1. So this equation, after substituting that T1 R1 and T2 R2, you will be getting ln of R1 equals to minus KT plus ln of R naught. From this, you find ln of R naught. Ln of R naught equals to, this one you keep it here only, take this side, then ln of R1 plus KT. The same way for R2, we take for R2 ln of R2 equals to T1 minus K T2 plus ln of R naught. Same here also you find ln of R naught. Ln of R naught equals to ln of R2 plus KT2. Okay, T2 here, there KT1. So here also ln of R naught, here also ln of R naught. Both are equal, right? It means that this part and this part are equal. So ln of R1 plus KT1 equals to ln of R2 plus KT2. You take this value to this side, this value to this side. Then ln of R1 minus ln of R2 equals to KT2 minus KT1. This one you know ln of x minus y. So ln of concentration R1, here it is, R2 equals to take K common, then T2 minus T1. From this you can find K, where K equals to, this one will come to the denominator, 1 by T2 minus T1, ln of R1 divided by R2. The difference between this one and the previous one is that previously we are discussing about when initial concentration and the concentration at any time is known, this one we will be using. And this one, if you know initial concentration and initial time, maybe if the reaction is happening for 10 minutes, you know what is the concentration at a 5 minute, 5th minute, and you know the concentration at a 6th minute. Then this, at these 2 points we will do. That is what this relation is about. Previously we are doing initial, means 0 second and some other second, 50th second, like that. That is the difference between this one and the previous one. So this is about first order reaction. This first order reaction is generally seen in, radioactive decay of isotopes, unstable nuclei. Radioactive decay. In the radioactive decay, generally it will be first order reaction. All natural and artificial radioactive decay. Unstable nuclei only learn to go, right? So unstable nuclei. We have an example, radium will change into helium particle and radon. Helium atomic number 2, mass number 4, plus radon atomic number 86 and mass number 222. This is an example. Next one, decomposition of N2O5 and N2O. And this is also first order reaction. We have one more example, hydrogenation of ethane. Hydrogenation of ethane. Or ethane C2, ethene C2H4 plus H2. C2H6, where rate of the reaction is proportional to C2H4 power 1. For this one, rate of the reaction R is proportional to RA to the power 1. For this, rate is proportional to N2O5 power 1. R is proportional to N2. That's all about today's class.